Alright, we're back to week 5 lecture notes, and I'm going to pick up where I left off in the last video. We were taking a look at how this formula was developed for finding any term in a geometric sequence. And let's go back to this formula you wrote down and do some labeling, because I want to make sure you understand it before we go on. This is the term you are looking for. The one you want to know, the one in the sequence you're looking for. This is the first term in the sequence. This is common ratio. That number you multiply by over and over again in the sequence. Remember, in this case, it was our 2 that we were multiplying by over and over again. And the exponent will always be 1 less than the term number you are looking for, the term number you want. If you're looking for the 10th term, this will be 9. If you're looking for the 21st term, this will be 20. Alright, make sure that's on a note card, because again, we're going to use it over and over again. In fact, we're going to use it right now as we look at the first problem on your notes packet. So this is about dominoes being lined up all in a row, and the first domino is 10 millimeters. And what it's doing is explaining that if I multiply that amount by 1.5, I get the height of the next domino, 15 millimeters. If I multiply that by 1.5, I get the next one, and so on and so forth. So I've got a geometric sequence where I'm starting with 10, and I am multiplying by 1.5 each time to get these successive dominoes, 10, 15, 22.5, 33 and 75 hundredths, 50 and 625 thousandths, etc. Each one of these terms is found by multiplying the preceding one by 1.5. And we could go on doing this until the dominoes are too big to be dominoes. Alright? And then, if we wanted to find the height of a particular domino, we've got a formula we can use, and that's the formula that we developed back here on our first page of notes, and it's also rewritten here. So to find any domino in the sequence, I'm going to do 10 times 1.5 raised to 1 less than the one I'm looking for. So let's say we want to find the height of, how about the 12th domino? So I'm going to use my formula, and I'm going to be finding A of 12. So again, it's the first term, A sub 1, 10, times my common ratio, which in this case is 1.5, raised to 1 power less than the term I'm looking for, so it's going to be 11. And if I take my calculator, I go ahead and type in 10 times parentheses 1.5 power up to the 11th power, and find out that that domino is really tall, 864.9, let's round to the nearest hundredth, 98/100 millimeters. Now, a millimeter is very small, but I have a feeling that's still a really tall domino. So maybe the sequence isn't good too much beyond what we see here on our paper.